welcome back. Today we shall study another coordinate system that is called cylindrical coordinate systems. There are so many physical problems in which we require a cylindrical coordinate system which is more convenient as compared to the Cartesian or spherical polar coordinate system depending upon the situation. So therefore we have to study what is called as cylindrical coordinate system. So in case of a cylindrical coordinate system, we have to consider a cylinder first. So I will draw a cylinder here. So this will be a cylinder here. This is the cylinder. Now along the height of this cylinder, I will consider this to be our z-axis. So this is our z-axis. Then I will write down it as a capital Z. Okay. So I will write down capital Z. Okay. Capital Z. Then we have, this is our y-axis along this direction, and this is nothing but our z-axis. Sorry, rather x-axis. This is our x-axis. So these are the x, y, and z coordinate axes. Now we have to consider any point on this cylinder. Say I will consider a point capital P over here. This is our point capital P, whose coordinates we have to consider as nothing but what? Rho, phi, and z as its coordinates. So I will write down it like this here. Rho, phi, and z. So these are the three coordinates. So what are these coordinates? So for that purpose, I will call this as O, and say I will call this point as say O prime if you want, O prime. Then if I consider this part here, this is point capital P. Is it right? This is point capital P if you want to write down here, or otherwise it is understandable. This is point capital P. Then this distance O prime P, and if I project this on this xy plane, the same point I will draw a perpendicular on the xy plane with. Then we will call this point as what? Capital Q point. Okay. Then the distance, this one, gives us nothing but what? This much distance, that is nothing but what? Radius. So rather this radius of this cylinder is nothing but what? It is one of the coordinate, and this is O prime P, or we can also call it as OQ. That is nothing but one of the coordinate, and we call this coordinate as what? Rho. Okay, so this is first coordinate. Then we have to consider the second coordinate. For considering the second coordinate, we have to consider the xy plane here again. See, this is our x-axis, is it right? I have drawn it in the 2 dimension in this way, but actually in 3 dimension our x-axis goes like this. Okay, so this is our x-axis. Then our xy plane is like this. So what we will do is we will put a perpendicular on this xy plane. Say that point we will call it as what? Point capital Q. Then the angle between x-axis and the Q, we will call it as nothing but what? That is nothing but our phi. That is, this angle is nothing but phi. And the third coordinate is nothing but the height of this cylinder. So if you consider this height of this cylinder from here to this O is nothing but what? Our z coordinate, which is same as the Cartesian z coordinate. Okay, so here we have three coordinates. One is rho, another is phi, and third one is nothing but what? Small z, okay, z coordinate. So what is rho coordinate? Rho coordinate is nothing but the radius of this cylinder, which we can consider from this figure as O prime P, or it is same thing as OQ. The second is phi. Phi is nothing but this angle, so we will call this as angle XOQ. So I will call here phi as angle XOQ. And our z coordinate, small z, is same thing as what? Height of this cylinder. So it is nothing but our, this I can call it as O prime, or also we can call it as what? PQ, because PQ is again that's z only, right? So it's because that is the height of the cylinder. So this is same thing as what? PQ. So this is what the cylindrical coordinate system is. In the next, as it is here, now we shall see the transformation equations. So these transformation equations we shall consider the Cartesian coordinates in terms of cylindrical coordinates as well as cylindrical coordinates in terms of Cartesian coordinates. So first we shall see the Cartesian coordinates, that is x, y and z, in terms of cylindrical coordinates, that is what? Rho, phi and z. So for this purpose again we have to consider the same cylinder here, but this diagram will be slightly different. So I will draw this diagram over here. So this is our z axis, this is our y axis, and this one is what? X axis. Y axis, this is x axis, and this is our z axis. Now what I will do is this part, that is nothing but this one part, I shall draw it separately over here. So it will be like this. Is it right? So this is our origin O, this is O prime, this is point capital P, and this point we will call it as capital Q. So rather I will draw it in a slightly better way, okay? Because it doesn't look very good actually. So we redraw this. We'll try this. Then this will be parallel to this here. So it should look like a plane over there. So this is our capital P point, whose coordinates are nothing but what? Rho, phi and z in cylindrical coordinates, and x, y and z in terms of Cartesian coordinates. So this point is capital Q. From this point we know that this angle is nothing but phi, which we had seen in our previous lecture. And I will draw the perpendicular on this y axis here. So I will draw it like this, so that it will be more visible. And again perpendicular on the x axis as well. So this distance is nothing but x. I will call this as n. So this distance is again x, and I will call this as n. And this distance, which is perpendicular on the x axis, this distance will give us y coordinate. And again this is y coordinate. Okay. So from this we have the three coordinates. Now third coordinate is z coordinate, which is same in both the cases, that is Cartesian as well as cylindrical coordinate system. Okay. Now we shall see what will be the x coordinate in terms of rho, phi and z. Okay. And similarly y coordinate and z coordinates. Okay. So for this purpose I have to consider one of the triangle here, either this ONQ or ONQ. So I will consider the triangle ONQ. So I will draw that over here. So this is our triangle ONQ. Now remember, this angle M is 90 degree. Similarly, angle N is also 90 degree. So this our triangle ONQ will be like this. This is our O, this is M, and this is Q. Okay. Now if this angle is phi, then this angle has to be what? 90 minus phi, and it means this angle has to be what? Phi. So angle Q here is nothing but phi, because the sum of the angles should be 180 degree in case of the triangle. So this is 90 minus phi, so this has to be phi, and this is our 90 degree. So 90 plus phi plus 90 minus phi, total will be 180 degrees. Okay. So next thing, this is our rho, which we have seen in the previous discussion. So this is rho. So that is nothing but OQ. So OQ is nothing but rho. And we see here that this QM or NQ, what is QM, is X, and QM is X, and ON is what? Y. So from this we can find out what will be cos of phi. Cos of phi is nothing but what? This is QM divided by this OQ or QO, whatever you want. OQ, I call it OQ. So this is equal to X divided by rho. So that's the first of the coordinate we get here is X is equal to rho into cos of phi. Then second, we will consider sin of phi. So sin of phi is equal to this opposite, that is OM, divided by this hypotenuse, that is OQ. So which is y divided by rho. So what we get here is y is equal to rho into sin of phi. So this is our second relation, and the third one is same thing, z as z, because it is same in both the coordinate systems. Z is equal to z. So this is our equation number 1, 2 and 3. These are very important equations. They are called as the transformation equations. That is cylindrical coordinate for the Cartesian coordinates in terms of cylindrical coordinates rho, phi and z. So we have x is equal to rho cos phi, y is equal to rho sin phi, and z is equal to z only. Now in our next part we shall find out what will be the rho, phi and z, that is cylindrical coordinates in terms of Cartesian coordinates, that is x, y and z. So for this purpose, what we will do is we will square these two equations and we will add them. So squaring equation 1 and 2 and adding it. So what will happen? On the on the left hand side we will get is x square plus y square is equal to rho square cos square phi and plus rho square sin square phi. So this is same thing as this is x square plus y square is equal to rho square, and inside bracket it is cos square phi plus sin square phi. But we know that this cos square phi plus sin square phi, it is nothing but what? It is equal to 1. So since this is 1, therefore we get rho square is equal to x square plus y square, and therefore rho will be, now what is rho here? Rho is nothing but radius of this cylinder, and that cannot be negative. So therefore it is always positive. Therefore we have to take a positive square root of what? X square plus y square. That is the rho, radius of the cylinder in terms of Cartesian coordinates. Okay. Now to find out the second, that is nothing but phi, what we will do is we will divide equation 2 by equation, we will divide equation 2 by equation number 1. So dividing this, so I will write down it in short, dividing this equation number 2 by equation number 1. So after dividing this, what we get is y divided by x is equal to rho sin phi divided by rho into cosine of phi. So this rho will get cancelled. So this is same thing as tan of phi. And therefore we can write down this phi is equal to tan inverse of y divided by x. So this is our second coordinate, phi in terms of what? Cartesian coordinates. And the third one is z is equal to z only simply. So we will get here these three coordinates. So I will write down these equations now again. So this equation I will call it as 4, 5 and 6. So I will write down it then here now. Now this figure is not required. So let's rub it. So our first coordinate, that is rho, is positive square root of what? X square plus y square. This is radius of the cylinder. It cannot be negative. So it will be always what? Greater than or equal to 0 is more than 0, and it can go up to infinity because the radius of the cylinder can go up to infinity. Okay. Now next coordinate is nothing but what? Our phi. So phi is equal to tan inverse of y divided by x. So it is having the range from what? 0 to 360 because it can totally move along that with the x-axis. Okay, angle with the x-axis. So its range will be 0 less equal 5 less than 2 pi. So I have written is less than 2 pi because again if it is equal to 2 pi it will become 0. Okay. Now next last coordinate is z is equal to z. So this can ideally go from minus infinity less than z to plus infinity in the any range because that is the height. Below x-axis, below z-axis if it goes, we will call it as the minus negative part, and if it goes above the above z-axis positive, above the origin, then we will call it as what? On the positive side. So these are again very important coordinates. We have called them as equation number 4, 5 and so we have to remember these relations for our further discussion. So thank you very much. We shall continue in our next lecture. Thank you.